Section 2.3, this is about limits again, but the computational part. We call them limits laws. So we suppose that the limit of a function of x as x approaches a and the limit of another function as x approaches a of g of x both exist and c is any constant. Then the first law says that the limit of the sum is the sum of the limits. The limit of the sum is the sum of the limits. This means you can pass the limit to the first function plus the limit for the second function. Even if you have 3 or more, you can pass to all of them. Same thing works for division, subtraction, and in law 2 and law 3. So for the difference, addition, and multiplication, they're all the same. For the division, it works the same way. You can pass the limit to the top, pass the limit to the bottom. But we need to make sure that the denominator is not 0, because we're not allowed to divide by 0. So again, the limit of the sum is the sum of the limits. The limit of the difference is the difference of the limits. The limit of the product is the product of the limits. And the limit of the quotient is the quotient of the limits. So those ones, this is the only one that I copy paste because it takes a lot of time to copy them. So we move on. The next one, if there is a constant times a function, you can pull the constant out. The constant does not affect the limit. And the last law says if you're finding the limit of a constant, it's going to give you the constant regardless what x goes to. It doesn't matter. It's going to stay constant all the time because there's no x's. And I prepared the first example to show you. How do we find the limit as x approaches 2 for x plus 11. X plus 11. So let me show you. It's a step by step. A lot of people think, yeah, just substitute the 2 in. Remember, limits is not about substitution. It's not exact. It's approaching. So what you do, the limit as x approaches 2 for the first one plus the limit of 11 as x approaches 2. So what do we get here? The limit, the limit of the sum is the sum of the limits. What do you get for the first one? So this is a straight line, y equals x. If you project it up at x, you will get 2. You don't have to graph it. Think about it as if you substitute it and you're going to get 2. And then this applies to property 6, which is a constant here, so you get the constant itself. And that would give us in return 13. Very easy. You just have to apply the laws when you are solving problems on the homework. Hopefully on the test there will be no free response. How about something like this? Do not just substitute the main in your head and give me the answer. So what you need to do here is write the limit of the first one as x approaches -3 minus the limit of the second one as x approaches -3. What do we get here? I see a constant 5. So if you go back to law number 5, you can pull that number out first. Limit of x as x approaches -3 and keep everything else the same. Here, as we did in the previous example, that's 5 times. Limit of this one is -3 minus the 7 is a constant, stays the same. -15 minus 7, -22. -22. Now I'm going to add 2 more laws. The first one is called the power law. The power law. The power law said the limit of f of x to the nth power as x approaches a is the limit of f of x as x approaches a to the nth power. So it means if you have something to some power, you can pass the limit inside. Then we have the root law. Root law says the limit as x approaches a, the nth root of f of x. You can pass the limit inside. Limit of f of x as x approaches a. These are the 2 new laws here. And I'll show you how to apply them. Very simple actually, just the steps are tedious. So say we're given this function x squared minus x plus 7 and we're asked to find the limit as x approaches 2. To do that, we find the limit of the first one, like this, as x approaches 2, minus the limit of the second one, as x approaches 2. I'm using the first two laws I stated at the beginning of this lesson, or this section. Now this one, the first one, x squared, that applies the power law, which says you can move the limit inside as x approaches 2, all square, minus, let's keep everything else the same. I don't have any constants to pull out, and the last one stays the same. Then this one is 2 as we did earlier, square. This one is also 2 as we did before, and that's a constant, stays the same. So you get 4 minus 2 plus 7, 2 plus 7, 9. It's very easy, as you can see, just tedious work. Any questions about this? Next one, try the next. I checked the answers. Some of you got it. Most of you got that. So here what we do is the limit of the quotient is the quotient of the limits. Limit of 8 minus 3x. Of course, you can put x goes to negative infinity every time. Then you do limit of the first one, limit of the second one, limit of the third one, over the limit of the first one, minus limit of the next one. Next, I see exponents here, so you do limit of x to the third power plus, take the 2 out, limit of x to the second power minus limit of a constant. Limit of a constant. I see 3, take it outside, limit of x. All this as x approaches negative 2. X approaches negative 2. We get negative 2 to the third power plus 2 times negative 2 squared minus 1 over 8 minus 3 times negative 2. That gives me negative 8 plus 8 minus 1 over 8 plus 6. These cancel. The answer is negative 1 over 14. Most of you got this answer. So the idea behind all this, how to use the properties of limits. Try the next one. So let's go over this. Again, we don't care about the answer as much as we care about the steps. So first you do the limit of the first one minus the limit of the second one as x approaches 0. Then pass the limit inside, x squared plus 1 minus the limit of the constant as x approaches 0. Under the radical sign, you do limit of the first one plus the limit of the second one minus the limit of the last one, stays the same as x approaches 0 in all of them. This one, we use the limit as x approaches 0 of x all squared. Keep everything else the same. When we are ready to pass the limit, we do it to all of them at the same time, which is now. So this is 0 squared 0 plus 1 minus 1. And that would give us the square root of 1, 1 minus 1. That's a 0.
Professor, is it okay if you zoom out a little bit so I can see the whole problem in one?
If I do what?
Just if you could zoom out just so I can see the whole problem together. 1 second.
But I need to go back because that will cause an issue later on.
Okay, that's perfect. I got it. Thank you.
So now, sometimes when we are finding the limits, you come across answers that might look weird to you. One of them is 0 over 0. So we don't know what 0 over 0 is. And another one, infinity minus infinity. Those two we don't know. Infinity minus infinity is not 0 because each infinity represents a huge number. They are different. We don't know what the value is. We can't take a 0 piece divided into 0 pieces. So in mathematics, mathematicians agreed that those ones do not have a value. We call them indeterminate forms. We can determine their form, the value. So what happens in this case is that since we call them indeterminate forms, those are not considered answers, So when they ask you find the limit and you get one of these, 0 over 0, infinity or infinity, those are not final answers. So we must we have to use a trick to get rid of this. The tricks that we use, I'm going to list them out right now. One of them is rationalizing, sometimes numerator, sometimes denominator, depending on the problem. That's when we have radicals. The other one is sometimes factoring can resolve the problem. You do factor and then you cancel. Expanding, it's another one, another trick. Combining fractions. If you see fractions, that usually happens for infinity minus infinity. Then you try to combine the fractions and it will take care of it. I'm gonna show you an example how this works. So they give me a limit problem like this. What I'm gonna do is I'm gonna pass the limit first. Don't do things in your head, but you have to show steps. Again, you need to also write x goes to 1, x goes to 1 in every step. So you get the limit of the first one minus the limit of the second one over the limit of the first one minus the limit of the second one. And this equals limit of x all square minus limit of 1. The bottom one stays the same. As x approaches 1, you get 1 square minus 1 over 1 minus 1. What do I get? 0 over 0. That's not an answer. This is indeterminate form, as we define it in mathematics. So we have to use one of those tricks. It's not two fractions or more to combine them. I cannot expand. There's no radicals to rationalize. So the only trick I can use is number 2, which is factoring. So what I can do, I can factor the numerator as x minus 1, x plus 1. Keep the denominator the same. So then the x minus 1 cancel each other. So that will leave us with finding the limit as x approaches 1 of x plus 1. So as you know, we find the limit of the first one plus the limit of the second one as x approaches 1. So that would give me 1 plus 1, 2. So that would be the answer. So I use the factoring trick to solve the problem. Any questions?
Professor, how
Yes.
about if the both if I do the both solution, but it's still the same, like the answer 0 over 0.
That's not, if you can, as soon as you factor it and cancel things out, then that will get rid of the 0 over 0 form. That's the idea behind it.
Okay, thank you.
We will have a section later on just to talk about indeterminate forms and show you different tricks to calculate them. Let's look at this one. You guys want to try this? So let's go over this one. Again, as the first step, if you notice what I did in the previous example, we want to pass the limit. Don't just write 0 over 0. You must show why it's 0 over 0. And then after that, you don't have to show it again. So you do limit on the top, limit on the bottom. So here you pass the limit inside, all square as h goes to 0, minus the limit of 16 as h goes to 0. The denominator stays the same as h goes to 0. Now inside that parentheses thing, you pass the limit, the first one. Limit the second one. Equals, limit of the 4 is 4, plus 0 square, minus, this stays 16, the bottom 0. This goes to 16 minus 16, 0 over 0. It would be nice to write indeterminate. Now, in this case, we can finish the problem in two different things. You either can expand or you can factor. Let's try to expand because we did factoring earlier. So the 4 plus h, was it 4 plus? Yeah, 4 plus h, you extend it as 16 plus 8h plus h square, and keep the minus 16 the same over h. These cancel out. So the limit, take an h out. 8 plus h over h as h goes to 0. Notice how these cancel out. All left to do is find the limit as h goes to 0 for 8 plus h. And this would give us 8 plus 0, 8. You don't have to do limit more because you already did it earlier. I want to show one more one. Yes, go ahead.
In the homework, should we like write both solution or only one solution?
Only one solution.
I got it. Thank you.
Next one, limit. The last example I want to go over. Of 1 over x minus 1 over x plus x squared as x goes to 0 plus.
Professor, I have a question.
Yes, go ahead.
So for the previous question, are we required to write the indeterminate step, or can we skip that one and go directly to the 8th one?
You have to show why it's 0 over 0.
Oh, I see.
Yeah.
No, I mean like for my work, so I don't write that step. So
No, you have to write this.
0 over 0.
So if this worth 10 points, 7 points goes to this.
Also, it's required. I see.
Yeah.
Yeah. Thank you, Professor.
So now in this example, there's a lot of things to learn here. The first thing is if you pass the limit to each one of them, so limit of 1 over x as x approaches 0 plus minus limit as x approaches 0 plus 1 over x plus x squared. What do we do for this one? How do we get this one? What is 1 over 0 plus? We don't know what that is, but you take that function, the 1 over x, and you graph it. Always when you pass the limit and there's a number on the top and 0 in the denominator, graph it. So we graph 1 over x. You can use Desmos to check that out. It goes this way and this way. So what this is saying, as we did in the previous section, as you approach 0 from the right side, what is the function going up to? Forever, to infinity. So this goes to infinity minus. You also graph this one on Desmos. Use Desmos to graph this. The graph will look like there's a vertical asymptote at 0 and another vertical asymptote at -1. It goes this way, and based on the graph I think it looks like this, and then another one here. That's the graph. Label everything when you graph it for homework and or test. So the question, what's the limit of this as x approaches 0 from the right side? If you come this way, where does the graph go? It goes up. So also goes to infinity. Infinity minus infinity is indeterminate again. So how do I clean up this indeterminate form? I see fractions, so what I'm going to do, I'm going to combine them by finding the least common denominator for LCD for x and x plus x squared, which is x plus x squared. So I have an x here. I need to multiply by 1 plus x, top and bottom. And this one, we already have it ready to go. Limit as x approaches 0 from the right side. Combine the fractions, x plus x squared, or if you like, x times 1 plus x. 1 plus x minus 1 on the top. These cancel. Limit as x goes to 0 plus x over x times 1 plus x. Again, the x's cancel. So then this goes to 1 over 1 plus 0. So the answer is simply 1. Any questions about this?
Professor, also when we have to find indeterminate.
When, what is it?
I mean, like when we have to find like indeterminate.
And it's not like when you find the limit and then you come across that form. You get either 0 over 0 or infinity minus infinity.
But sometimes actually, sometimes we go through to number 1 directly. So it's accidentally we go through to number 1 directly.
How can you go to number 1 directly?
I mean, if I know how to solve it direct to the number 1.
No, you have to show the limit steps.
Okay.
There's no way around this. There's no way to go around this. You must show the indeterminate form.
Okay, thank you.
So he's saying he wants to go straight from here to here. Don't do that. You must show the indeterminate form. Because why you thought like to combine them? Because you got indeterminate form. Because sometimes you might find the limit and then you got an answer like right away. It's not indeterminate form and you can just finish it there. You have a question?
Professor?
Yes, go ahead.
When did you get 1 plus x again? Like, why are you multiplying it by 1 plus x?
Because the least common denominator is x plus x squared. So it's x times 1 plus x. That's what it is. So here I had the x available here. So I'm missing the 1 plus x because of the least common denominator.
Oh, okay, I got it. Thank you.
Mm-hmm. Notice a lot of things we do here, the algebraic part is from the journey of calculus or journey to the calculus. Very important. There's LCDs there, there's domains, there's how you combine fractions. You come across them here. You will see that the calculus part is only 10% of what we do, and the rest is either trig or algebra. Any other questions? So we finished about 3/4 of 70%, I would say, of this section. So the other part, there's examples about you got 0 over 0, but you have to do rationalizing, or if you have an absolute value, how you work it out. And then there is something called the squeeze theorem. So those ones, you find them in the other recorded video. And also make sure you go over section 2.4 on Wednesday. Or any time, before Friday.